boys and girls, today we're going to be talking a little bit more about place value and looking at 3-digit numbers all the way to 1,000. I'm going to ask for 2 friends to come and help me today, and they're going to practice what we did yesterday when we were modeling our numbers using place value disc. I'd like for Parker A to come up to the board, and I want you to show me, by modeling using your place value disc, I want you to show me 141 on this chart. Once everyone look and see. Now Parker is going to use the 10 frame way to represent his numbers so that it makes it easy for us to count. Great, Parker. Tell me how many 10s, 1s, and then 100s you needed to represent the number 141.
I needed 2 1s, 4 10s, and 100.
Very good. So we're going to do 141. So we have 100, 4 10s, and 1 1. Thank you. Awesome. Now, boys and girls, we talked a little bit about changes and exchanges. If I'm going to make an exchange, I'm going to take something and get something different. Can I change the 100 into 10s?
Yes, ma'am.
Somebody raise their hand and tell me how many 10s would I need if I wanted to change my 100s to 10s.
You would need 10 10.
Good. Aiden, would you come and make that change for me, please? So Aiden is going to take his 100 and he's going to change it into, everyone, 10 10s. Very good. Oh, I love the way Aiden is using the 10 frame way, and he's starting on the 4 and building up 5, 6, 7, 8, 9, 1, 2, 3, 4, 5. So now we built a 10. How many have you added so far? How many have you added so far? 5, 6, 7, 8, 9, 10. Now we exchanged our 100 to 10 10s. Do these place value chips still represent 141? Yes. Let's count them together. Ready? Here we go.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 141.
Very good. Now, we can also make an exchange. An exchange is when we take something and get something different. So we're going to exchange our 10s back into a 100. Very good. Ben, would you come and do that for us, please? Ben is going to make an exchange. He's going to take 10 10s and he's going to make 100. Put thumbs up or thumbs down if you think the number is going to remain the same. Very good. Very good. Thank you. So let's watch and see what Ben does there. Very good. Did Ben make that exchange?
Yes,
Yes. What number do I have represented now?
141.
Somebody tell me, why do you think it's important that you know how to make a change and an exchange? Parker A.
Well, it's important because if you don't want to count 100 ones and you want it to be easier, wouldn't it be easier just to do 10 10s rather than 100 ones?
That would. Raise your hand if you think that'd be easier to count 10 10s instead of 100 ones. Yes, it would. Do you think there's ever a time when you're going to have like 18 ones? And you have to count all those out? Could you easily make an exchange for a 10?
Yes.
Yes. And that's going to help you when you're adding and subtracting to know that you can make those changes and exchanges. We're going to look now at a number line. And we're going to see how can this information, using place value chips, help us count on a number line. I want you to look at your paper. We are going to count on our number line using the arrow way. On the arrow way, you're going to be making hops or jumps. And what are those jumps that we make? Sammy?
Hundreds, tens, or ones.
Hundreds, tens, and ones. So we're going to use those jumps of hundreds, tens, and ones. How do you think that's like the place value chips? Kennedy?
Because on the place value chips, there are hundreds, tens, and ones.
Very good. So we're going to start at 0 on our number line, and we're going to use the arrow way method, counting by hundreds, tens, and ones, and we're going to make those jumps all the way to 141. I want you to pick up your pencil and show me on your number line how you would use the arrow way method and the place value to help you count by hundreds, tens, and ones all the way to the number 141. Almost everyone's ready. I'm going to pick some friends to share with us. Who wants to share with me? Okay, let's do it together. So you said you did 100, and that gave you. And what did you do next?
And I did a plus 10, which gave me 110. And I did another 10, which gave me 120. I did another 10, which gave me 130. Another 10, which gave me 140. And then plus 1 gave me 140.
Very good. Make sure, put thumbs up if this is the way you did it. Thumbs up. Did anybody do it a different way? Kaden, how did you do it?
I did plus 10.
Okay. So you said,
And then I did a plus 100, which got me to 110.
okay.
And then I did another 10. And another 10.
And that 10 made you have,
130.
okay.
And then I did one more 10 jump to get to 140.
And then you did,
A one jump and to get me to 141.
are both of these answers correct?
Yes.
Yes. Why? How can we do it so many different ways? Did anybody do it a different way? Parker did it a different way. Parker T. Will did it a different way. Somebody tell me why it's okay that these two are different, but yet they're still the correct answer. How are they the same, Kennedy?
They don't have, they have more than one right answer.
There's more than one right answer to a problem. Parker?
They equal the same thing.
Very good. How many 10 jumps did I make on the top line?
4.
How many 10 jumps did I make on the bottom line?
4.
How many 100 jumps?
1.
How many?
1.
And how many ones?
1.
Very good. Boys and girls, there are many ways to solve a problem. Can somebody tell me how the place value chips might help you work the arrow way on a number line? Reese?
The place value discs are the same thing. They just help you add and subtract kind of. And they have numbers, which will kind of help you get the idea of what to do on a number line.
They will help you by giving you an idea. Very good. Does anybody else have another way they may be helpful? Parker?
But there is, you still do the same jump. You still do the same kind of jumps. But there's one thing that's different.
Okay, tell us what's different.
Well, you don't have to do like one by one by one. You could do like 40, or you could do like 200 if that's the number you need.
You can make larger jumps. Very good. Guys, we're going to look at one more way that those place value chips could help us. Let's look at the bottom where we have all of these blanks. If we had the number 570, how many hundreds would be in that number? 5. How many tens would be in that number?
7.
What if I made some changes? What if I had to represent that number, 570, only using tens? Jackson. 57 tens. Raise your hand if you think that's correct. Awesome job. You guys are so smart. Hands down. Let's do some more like that one. What about the number 748? How many hundreds are in 748's ahead?
7.
How many tens? They didn't ask me for tens. They asked me for ones. So what could I do there? How many ones would I have if I have 700s? How many ones would I have?
40.
Elizabeth?
48.
48. Very good. So let's look at that same number, 748, but I'm going to represent that number only in tens and ones.
Come here.
Parker, T.
74 tens.
Okay. And how many ones, Parker, T?
8.
8. Very good. And our last one, 909. How many hundreds?
9.
How many ones?
9.
What if I represented that number in tens and ones?
There are 90 tens and 1.
Very good. How do you think using a place value chip would help me when I need to identify numbers like that quickly in my head? How did using those place value chips help us do that quickly? Kennedy?
If you're using 909, like you have 9 tens and you have 9.
Very good. Okay, everybody, pencils down. Eyes on me. I have one more question. If I were adding a number that had a lot of ones, would I know, or would you know, how to make changes and exchanges to get that answer? Thumbs up or thumbs down? Tomorrow, we're going to be looking at ways to add numbers when we have lots of ones or lots of tens, and making those changes and exchanges. Okay, thank you. Hands down. Good job, boys and girls.